BCA Computer Networks. Unit 1. Layers of TCP IP models.
4 layers of TCP IP models are Network Access Layer, Internet Layer, Transport Layer, and Application Layer.
Basically, we can say that TCP IP is the implementation of OSI models. Did you remember the 7 layers of OSI models, which are Physical Layer, Data Link Layer, Network Layer, Transport Layer, Session Layer, Presentation Layer, and Application Layer?
For better understanding, click on the I button to watch layers of OSI model. Now here in TCP IP model, the application layer is playing the role of application, presentation, and session layer of OSI model.
The transport layer remains the same.
The network layer becomes internet layer in TCP IP model.
And at last, the data link layer and physical layer becomes the network access layer.
Now let's start with application layer. This layer is the topmost in the TCP IP model and is responsible for applications and programs that utilize the model for communication with the user. It performs various tasks, including data representation for user-executed applications and forwarding data to the transport layer. The application layer ensures a smooth connection between applications and users, facilitating data exchange. It offers various features such as remote system management and email services.
Several protocols are used in this layer, including HTTP, Hypertext Transfer Protocol, used for accessing information on the Internet. SMTP, Simple Mail Transfer Protocol, manages email-related tasks and issues. FTP, File Transfer Protocol, standard protocol for file transfers over a network channel.
Now here we have transport layer. This layer is responsible for establishing a connection between sender and receiver devices. It divides data from the application layer into packets, creating sequences for transmission. The layer ensures error-free data transmission and controls the data flow rate for smooth communication.
In this layer, 2 main protocols are used. First, TCP, Transmission Control Protocol, responsible for proper segment transmission over the communication channel. Establishes network connections between source and destination systems. Second, UDP, User Datagram Protocol, handles error identification and other transmission-related tasks. Maintains various fields for data transmission, including source port address, identifies the application creating the message. Destination port address, receives messages sent from the sender. Total length, specifies the total number of bytes in the user datagram. Checksum, used for error detection at the destination side.
Moving further, here comes internet layer. This layer controls data transmission over network modes and enacts protocols related to data transmission in the form of packets from the previous layer. Its key functions are: it specifies the path for data packet transmission, provides IP addresses for system identification on the network channel.
Here are some protocols used. First, IP, Internet Protocol. Assigns unique IP addresses to devices. Responsible for routing data over the communication channel. Second, ARP, Address Resolution Protocol. Finds physical addresses using IP addresses. The Internet layer in the TCP IP model performs essential functions related to data transmission and network addressing.
Now finally let's discuss the last layer, which is network access layer. This layer combines the data link and physical layers and handles the sending and receiving of data in raw binary format over the physical communication modes in the network. It uses the physical address of the system to map the path of transmission over the network channel.
At this point in this tutorial on the TCP/IP model, let's compare it with another network model. This layer in the TCP/IP model is responsible for the physical transmission of data and utilizes physical addresses for communication.
For more updates, follow the BCA World on Instagram and subscribe the BCA World on YouTube.